Hi everybody. This video is to help those of you that want to watch a video or listen to audio and learn about our key terms and the knowledge behind Chapter 1. So to start off the year, you should create a Google document that you can use and edit for the remainder of the school year. So I would call the document your last name, Electronics 2018 Notes. And you'll be able to update this throughout the school year, and if needed, you can add a link to like a turn-in in Google Classroom to show that you're making progress on this. So I can check this occasionally. If you're not a technology person and you want to do this with pencil and a paper and a notebook, that's another way to do that. If you have another method you'd like to use, please ask me before starting that. All right, so most of you should have some background of science and things such as the atom. So an atom there's an atom for all the different elements that we know of. And an atom is stable, so it has the same number of electrons to protons and even neutrons. It has the same amount. So carbon has 6 of each. So electricity is defined as the flow of electric charge. Charge is a property of matter, just like mass, volume, or density that we can find, that can be measured. So just as you quantify how much mass something has, you can measure how much charge it has as well. The key concept is that it comes in 2 types, positive and negative. So in simplest terms, for electricity to flow through a conductor, an electron moves from one conductor's atom or element to the next. So copper, say these are copper atoms next to each other. One electron from the copper atom is being lost and transferred to the one next to it. And if that happens, then electricity is flowing, or current is flowing. An electron, again, is a negatively charged particle. A proton is a positively charged particle. And a neutron has no net electric charge. A conductor, according to Merriam-Webster for the dictionary, is a material or object that permits an electric current to flow easily. So examples: metal, water, and your body. And why is your body a good conductor? Well, that's because a large part of your body is made up of water. And some good examples of conductors would be copper, aluminum, steel. Those types of metal are very good conductors of electricity. An insulator is a material that is a poor conductor as of electricity or heat. So it's a device made of an electrical resisting material that is used to support or to separate conductors. So can you think of some good conductors of electricity? Well, maybe you thought of things such as rubber, but maybe some others that you did not think of would be glass or wood. Those are three really good insulators of electricity. Voltage. Voltage is an electrical potential or potential difference expressed in volts. So just remember, voltage is a potential of electricity. So we can measure voltage across a circuit, we can measure it across a battery, we can measure it across a component of a circuit. So like across the positive and negative legs of an LED, we can measure that. Amperes is a unit of electrical current. It's the rate of flow of electricity. An item that conducts electrons well has a higher ability to carry current. So conductance is related to amperage. And we usually just call these as amps. An ohm is a resistance between 2 points of a conductor. So if we have a wire that at one end has 13.2 volts at its input, and over a length of it, it loses 0.1 volts simply because of its either size of the conductor or the length of the run. Other items can be installed into circuits to create specific ohm values to get the voltage to drop to acceptable levels. Very often a resistor is used with LEDs to get the LED voltage down to 3 volts compared to 6 volts or 9 volts for its input power from a battery. The ohm measurement can increase significantly if the conductor is in poor shape. Things such as corrosion, poor connections, poor connectors, poor test equipment will show a higher ohm reading than what might have been there originally. And the symbol for ohm is the Greek omega symbol. Ohm's law. Using the terms of voltage, amperage, and ohms, we can create a set of algebraic equations. We have V, which is the electromotive force or potential, which is called voltage. Sometimes in the Ohm's law chart, we'll have an E instead of a V. We have I, which is relating to conductance, the ability to carry current, which is amperage. And we also have R for resistance and ohms. Ohm's law charts can be helpful. You shouldn't rely on them. But at the beginning, it might help to remember which way we can think of the order of operations for these to solve these problems. Some also include 4 parts. They include power. The one on the top right, the circle, includes power, so electrical power. Wattage. You've heard of watts before. That's electrical power. To solve for voltage, we take amperage times ohms. So we simply separate the top, voltage, and multiply the 2 bottom parts. To solve for amps, we take voltage divided by ohms. So we take our amperage, we separate it, and that leaves voltage over ohms.